Good afternoon. We are going to be taking notes on 10.3 arcs and central angles. So there's quite a few pages today, so we're going to move through fairly quickly, so be on your toes. Okay, Roman numeral 1, arc vocabulary. Definition of a central angle is an angle with its vertex at the center of the circle and its two endpoints on the circle. So if I wanted to draw a central angle, I could draw one side up here and call it A. I could draw another side here and call it B. And that would be angle ACB. You could always have to use 3 letters to designate a central angle. The measure of a central angle must be greater than 0 and less than 360 degrees. So, for example, this central angle would be 40 degrees, A to C to B. Okay, so example, measure of angle AOD, A to O to D, equals 100 degrees. Question, which way do you measure the angle? You always use the acute angle as the default. In other words, always go the smaller way. So that's the measure of angle AOD. In order to designate a larger angle, we use the B here, and we say we're looking for the measure of angle ABD, which means use the central. And of course, if this is 360 minus 100 is 260 degrees. So you have to have a third point to indicate a larger angle. Okay, definition of an arc. An arc is an unbroken part of a circle. Arcs are measured in degrees with the same measure as the central angle that transects it. So the symbol of arc AB is a little arc over the top and AB, and you can use that, or you can say arc BA. They are reversible. So for example, if the measure of angle AOB is 60, then the measure of arc AB is also 60 degrees. So this arc from here to here, 60 degrees, matches the central angle that makes it. And that's what transect means, is it makes the arc. All right, flip the page. Minor arcs. So we have minor arcs, we have major arcs, and we have semicircles. For a minor arc, it's the shorter arc in the circumference of the circle. It measures less than 180 degrees, and it's the default angle. It's the one being, unless it's noted otherwise. So in this picture here, arc DE is a minor arc. We use the acute angle to designate that arc. Minor arcs are written using its two endpoints. For example, the measure of arc DE, you would say lowercase m, capital D, capital E with an arc over the top of it, equals, and of course it would have the same measure as the angle that transects it, so it would be 85 degrees, just like the central angle. Okay, major arcs. The major arc is the longer arc. Sorry, my pencil's dead. Is the longer arc in the circumference of the circle. This is the arc that measures more than 180 degrees. Major arcs are denoted using 3 letters. So major arc with endpoints A and C would go from A all the way around to C. That would be arc AB. BC. You have to give that middle letter. Major arc with endpoints C and B, so from here to here, can't be denoted without another letter because there's no letter. So we're going to add a point E here, and from C to E to B. C, E, B is the major arc. Okay, example 3. Find the measure of arc DFE. So we're looking for arc D to F to E, which is this one. We have that angle DOE, excuse me, is 140 degrees, which means that the measure of arc DFE is 360 degrees minus 140, which means that the measure of arc DFE is 220 degrees. So this would be 220. All right, semicircle. Semicircle. A semicircle is an arc with a measure of exactly 180 degrees. Semicircles are labeled using 3 letters to distinguish clockwise and counterclockwise direction. Its endpoints are on a diameter of the circle that passes through the center. Okay, so looking at this, here's our diameter, which is from X to Y. You can tell it's a diameter because it crosses the center. And the example says if XY is on the diameter of circle O, which it is, name the semicircles. Okay, so if we want to go this way, that would be semicircle XZY. If I want to go the other way, I have to go XUY. And both of those are semicircles. So there's always 2 semicircles in a circle. All right, flip the page. Okay, example 2. Label the semicircle with the endpoints on G and H and passing through F. Okay, so endpoints on G and H. So here's G, here's H, and passing through F would be here to here. And of course, G and H are on the diameter. So that would be arc GFH. Okay, name the semicircle with endpoints on G and H, but not passing through F. So if it's not passing through F, it's got to go left or counterclockwise. And that would be arc GIH. Again, the endpoints of a semicircle are on the diameter. Okay, adjacent arcs. Adjacent arcs are arcs that have exactly 1 point in common. So if we look at arc U to R, an arc that is adjacent would share an endpoint. So R to S would share an endpoint. U to T would share an endpoint. All right, if we look at U to S, which is from here to here, adjacent arcs, arcs that share the endpoint, would be UT and ST. Okay, the last one, given arc UST, so U to S to T, that goes around there. Does it have any adjacent arcs? It does not. It can only have 1 endpoint in common, and the only arc that's left would be U and T, and that's 2 endpoints. So there are none that are adjacent arcs. All right, congruent arcs. 2 arcs that have the same measure are congruent arcs. If the 2 arcs are from 2 different circles, then the circles are not necessarily congruent. They might have different radii. So you got to be careful about congruent arcs. So looking at this one, we have an arc here that's going to be 87 degrees, like the central angle. This one, DE, is 87 degrees. And GH is 87 degrees, but you can tell these circles are completely different sizes. So just because they have the same arc measure does not mean they are the identical same size of circle. So the measure of angle AOB equals the measure of angle DPE equals the measure of angle GQH, and all of those equal 87 degrees, which means angle AOB is congruent to angle DPE, which is congruent to angle GQH. The angles are congruent. With only the angle measurements, it is not possible to determine if the circles are congruent or have the same radii. So you can't know that from just the angles. Consider the radii. The radius of circle O is 3. Circle P is 3. Circle Q is 1.5. So based on that, circle O is congruent to circle P because they have the same radius, but it's not congruent to circle Q because they have different radii. All right, flip the page. Arc addition postulate says the measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. Now this sounds a whole lot like segment addition postulate or angle addition postulate. In both cases, you have the measure of the entire piece equals the measure of arc part 1 plus the measure of arc part 2. Part plus part equals whole. Okay, so I need to fix these. I got these wrong. So the measure of arc ABC, so A to B to C is here, A to B to C equals the measure of the part AB plus the measure of the other part arc BC. Okay, so on another one, the measure of arc ABC, since we know those measurements, 110 degrees plus 90 degrees, we can do part plus part equals whole, so we know that the measure of arc ABC is 200 degrees by adding the measures of the parts together. Part plus part equals whole. Okay, 9.3, this is a theorem. It says, in the same circle or in congruent circles, two minor arcs are congruent if and only if their central angles are congruent. Okay, so given circle P with arcs DE and DF. With DE and DF, so if angle DPF is congruent to angle DPE, so if this angle and this angle are the same, then using this theorem, we can conclude that arc D to F is congruent to arc D to E. So this arc and this arc are the same. So congruent arcs have congruent central angles. Congruent central angles have congruent arcs. Flip the page. Okay, inscribed angle measures. Definition: inscribed angle is an angle whose vertex and endpoints are on the circle such that the center of the circle is inside the angle. Okay, So this is inscribed. So angle RTS, so R to T to S is this one. Angle RTS is inscribed in circle O because its vertex and two endpoints are on the circle. Angle ROS, R to O to S, so that one, is a central angle because its vertex is the center of the circle. So an inscribed angle does not contain the center of the circle, but a central angle has the center of the circle as its vertex. All right, let's do the theorem. The measure of an inscribed angle is equal to half the measure of its intercepted arc. Okay, so in the picture, inscribed angle, which would be DFE, is equal to 1/2 of the arc measure. So if DE is the arc and it is 150 degrees, it means that the inscribed angle is half of that, which would be 75 degrees. All right, so we basically just did this. If circle Q has arc DE equal to 150, then the measure of angle D to F to E, which is our inscribed angle, equals 1/2 of 150 degrees, which means the measure of angle DFE is 75 degrees, half of the 150. Okay, flip the page. Okay, these are some practice problems. Number 1 says, give the measure of each angle or arc. Okay, so they've given us a 30-degree central angle and a 50-degree arc, which means this little angle in here is 50 degrees and XY arc is 30. So this is the measure of arc WX. Okay, so this is arc WX is what? Okay, so Y to T is a diameter, and that's important because the diameter splits the circle into 180 degrees and 180 degrees. So to find the measure of arc WX, I have to take 180 minus 30 minus 50. So 180 minus 80 would be 100 degrees. So this is 100 degrees, which means the central angle is 100 degrees. Okay, the measure of angle WOT. This one, well, if the arc is 50, the central angle is 50 degrees. Okay, the measure of arc YZT. YZT. So from here all the way around with its endpoints on the diameter means that's a semicircle, and the arc measures 180 degrees if it's a semicircle. Okay, the last one, the measure of arc XYT. XYT would be from here over to here. So that would be 180 for the semicircle plus 30, which is 210 degrees. So be sure you know where your diameters are. Okay, number 2. Now answer the questions using the figure provided. If the measure of arc NQ is 50, then the measure of angle 1, this one is the inscribed angle, is half of that, which is 25 degrees. And the measure of the central angle that makes the 50 degrees is the same. So that central angle would also be 50 degrees. Okay, it says if the measure of angle 2 is 30 degrees. Okay, so let's say angle 2 is 30. then the measure of angle 1 is what? Okay, so if this is 30, then NQ is 30, and angle 1 will be half of 30, which is 15 degrees. Then the measure of arc NQ, if the interior angle is 30, the arc that it transects is also 30. All right, last practice. Find the measure of each arc using the angles provided in the figure. So we're going to write an equation and solve it. So first thing we can do is figure out what x is. So since d to a, right here, that's a diameter, that means 4x plus 2x has to equal 180 degrees. And you solve that and you end up with x equals 30. Okay, so now that you know what x is, angle E to A is 2 times x, so 2 times 30 is 60 degrees. E to D is 4x, so 4 times 30, which is 120 degrees. And then D to C is 2x minus 14, so 2 times 30 minus 14 is 60 minus 14, or 46 degrees. All right, that about wraps up our notes. I highly recommend you use your notes while you're doing your homework to be sure you remember. Have a good day.